Hi everyone, here is the video presentation for SQQM 2023 Linear Algebra, Semester A202, Group B. Our lecturer is Dr. Abdul Malik Yaqub. Our topic is constructing curves and surfaces through specific points. And this video presentation is prepared by Group 10. The group member involves Jocelyn Auyen Y, matrix number 276918, Arif Aizal bin Muhammad 277359, and Olivia Lee Pao-Ying 278420.
Okay, for introduction, first of all, constructing curves and surfaces through specific point is a technique where determinants are used to create lines, circles, and general conic sections via defined and fixed point in the plane. The technique is often used to move planes and space through fixed points in 3D space. So below is the general equation of the curve or surfaces. First, equation of the line in general form, ax plus by plus c equal to 0. Then equation of the circle in general form, ax squared plus by squared plus cx plus dy plus e equal to 0. And lastly, the equation of the conic section in general form, ax squared plus by squared plus cxy plus dx plus ey plus f equal to 0.
So now I'm going to present about the simple curves and surfaces that are commonly used in real-life applications. There are 4 types of curves that are commonly used in different fields. First is circles, second ellipse, third hyperbola, and fourth parabola. The following formulas for respective curves are displayed in the slides. For surfaces, there are also 4 main types of surfaces that are commonly used in different fields. First is ellipsoid, second is cone, third is elliptic cylinder, and fourth is elliptic paraboloid. The diagrams and the formulas for all the following surfaces are shown as the following. Next, I will also talk about the application of constructing curves and surfaces through specified points which are applied in different fields. So here we pick 4 types of fields where curves and surfaces plays a very important role. So the first one is computer graphics, second bioinformatics, third typography, and fourth in physics. First of all, the application of constructing curves and surfaces through specified points is used in computer graphics, or as we call computer-aided design, CAD. CAD is used in many different types of fields, but we chose to pick engineering. So in engineering, a design of any high-performance device, for example, a jet engine, is almost entirely done using computer visualization software to produce their prototypes. As we can see from the diagram here, so here we create components of a jet engine using the elliptic cylinder surface. Secondly, constructing curves and surfaces through specified points are also used in bioinformatics. In this field, we use a method of curve fitting in the process of gene sequencing analysis. And to explain it in a simple way, during the process of gene sequencing analysis, different surfaces arise in several contexts. For example, molecular surfaces, solvent-accessible surfaces, and also others. Next, the third application is in typography. Typography is the art and technique of arranging shapes to make written language legible. So in this case, constructing curves and surfaces through specified points is used to make font design. The importance of font design is to set the overall tone of different websites and ensures a great user experience. Last but not least, curves and surfaces are also used in the field of physics. In this case, Euler angles. Euler angles are the basis of theory of rotating bodies in physics, which is a theory of rational behavior of planets, spacecraft, gyroscopes, molecules, and atoms. Euler angles are a tool in elementary particle physics. So as the diagram is shown, these are the 3 basic steps of Euler angles. So let's see example 1. Given that the points E 7, 7 and F -2, -5, find an equation of a line passing through both points. In order to solve example 1, our first step is to substitute the value of E and F into the general equation, and then we will get a system of linear equation. And from this system of linear equation, we generate it into the matrix form. The matrix equation AX equals to B has a non-trivial solution if and only if determinant A equals to 0. So in order to find determinant A, we use the diagonal method and we equals it to 0. So from here, we just expand and simplify the equation and we will get that 4x minus 3y minus 7 equals to 0. So therefore, we can conclude that the equation is 4x minus 3y minus 7 equals to 0. Here we plotted the graph of 4x minus 3y minus 7 equals to 0, and it can be seen that this line can be obtained through two given points E and F.
Next, for the example 2, given that the 3 points E, F, and G had passing through the circle, find the equation. Through the solution, the first step is by substitute E, F, G and a general point H, we can obtain the below homogeneous linear equations by using general form ax squared plus by squared plus cx plus dy plus e equals to 0. So here is the equation. The linear system in the matrix form can be written as ax equals to b. Here is the matrix form for A, X, and B. The matrix equation Ax equals to B has a non-trivial solution, which is a non-zero solution, if and only if determinant A equals to 0. Here is the solution for determinant A equals to 0. We can find that determinant A equals to negative 4x squared minus 4y squared plus 16x plus 24y minus 44. So since determinant A equals to 0, therefore negative 4x squared minus 4y squared plus 16x plus 24y minus 44 equals to 0. Hence, we can conclude that the equation of the circle is x squared plus y squared minus 4x minus 6y plus 11 equals to 0. Here is the visual aid for the circle. The circle with the equation x squared plus y squared minus 4x minus 6y plus 11 equals to 0 can be obtained through these 3 points E, F, and G. In summary, the equation of a curve or surface are able to calculate through the linear algebra with the given points. The linear algebra theorem that states a matrix will have a non-zero solution if the determinant is equals to 0 exactly can be applied to construct the curves and the surface.
Okay, lastly for the conclusion, the application of linear algebra is essential in constructing curves and surfaces, such as we can use determinant, terminology, and many more to solve complex equations. The combination of linear algebra and curves and surfaces can help solving majority of real-life problems, such as in engineering design or building a perfect stable bridge. In ecology, we can use curves and surfaces to see the curve of temperature that global warming exists, and we can use the curves and surfaces to predict things too. So basically, curves and surfaces provide an efficient means in each all the things and problems around the world. Here is our group reference. We use a total of 5 references in creating our slide and in referring about the topic that we had choose. So that's all from our group. Thank you sir and thank you everyone.